Hi everyone, in this video we're going to talk about some special logarithms and we'll do some more examples. So the first logarithm we're going to talk about is called the common logarithm. So common logarithm. So the common logarithm is written just log x and the base is hidden. So whenever the base is hidden, it's log base 10 of x. Okay, so it's so common that people don't write the 10. Okay. The other one is really important. It's called the natural logarithm. Natural logarithm. And so the natural logarithm is written ln x. So whenever you see ln, just assume that the base is e. Okay, the base is e. It's called the natural logarithm because e is the natural choice for the base. Okay, so it turns out, just a quick aside, I hate to derail, but I have to tell you this is so cool. If you graph e to the x, which we've seen before already, e to the x is the only function in the entire world besides 0 where the height is equal to the slope. So these are equal. So the height is equal to the slope at that point. It's the only function in the entire world besides 0, which is boring. So that's why it's called the natural logarithm, because it's the natural choice for the base. This function is extremely important in calculus. Okay, so let's go ahead and just do some more examples of computing values. And as we go through the examples, some other formulas will arise. So compute. Okay, compute. So A, use a different color. Let's see. So start by computing log of 100. You can actually just put this one in your calculator and you'll get the answer. But the base here is 10. There's an invisible 10. I'm going to go ahead and write it. So the question is 10 to what power gives you 100? So 2. And that's because 10 squared is equal to 100, right? 10 squared is equal to 100, so it checks. Let's do another one, B. But if you had ln E. Again, you can put this in your calculator as well. Anytime you have a log or an ln and it's just numbers here, your calculator has these keys. So the base here is e. So the question is e to what power is e? So the answer is 1. Right? There's an invisible e here. So e to the 1 is equal to e. E to the 1 is equal to e, so it checks. C. This one's really important. ln e to the x. Okay. The question here is e to what power is going to give you e to the x power? Well, x. Right, so this is a formula. You want to memorize this. Basically, the ln and the e cancel. This is super useful. Super useful. Probably one of the most useful formulas ever. So super, super useful. D. This is just a formula. If you have e to the ln x, you get x. Okay. Very, very key. Again, very important, super useful. Want to memorize it. Super useful. Now we can do some examples based off these two formulas. Say we had ln e to the x squared. Well, the ln and the e cancel. Boom. So you just get x squared. Piece of cake. F. Let's keep going. E to the ln x squared plus 2. Well, the e and the ln cancel, right? That's what this formula says. Boom. You just get x squared plus 2. That's the answer. Let's keep going. A, B, C, D, E, F. Let's do G now. I'm going to switch colors here. Too much yellow. G. ln e to the x over 2. So again, the ln and the e cancel. Piece of cake. And you get x over 2. That's the answer. H. H. E to the ln of x minus 7. Again, the e and the ln cancel, you get x minus 7. So the point is, e and ln, these guys cancel, right? So these cancel and these cancel. Very, 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 very useful. I can't think of anything else that's critical to go over in this video, so I think I'll stop it here. That's it.